So the midterm on Thursday will be in this room right here. Make sure you spend some time at the end of class making sure that you can log on to the computer, you can open up SAS, you can read in a SAS data set into your SAS session. Also make sure you can open up Word and do some nice copy and pasting similar to what you may expect on the exam. If you haven't already written this down, in order to log on to the computers in this room, SNR again has certain security measures set up so that you can't use your UNL-AD account like you can in most places on campus. And instead, what you have to do is use this login and password, SNR user, and then the password is HHGuess exclamation mark. So a great way to remember the password is Hardin Hall Guest, and you're really happy to be here. In past passwords that they've had in these classrooms, they've even had 2 exclamation marks, so you're really happy of being in one of their classrooms. So, again, by the end of class, or before you leave today, try to make sure that you can log on and do other stuff. Okay, also just as a reminder, assignment number 3 is due on Wednesday of next week at noon. Are there any questions before we begin today? Or I should say, we will also have a review later today. Are there any questions before we start? Okay, so we're going to finish up quickly this LaTeX stuff and get into LyX. Let's see here. Where's my LaTeX document? Oh, did I close it out? Yes, I did. Oh, shoot. Oh, this isn't good. Sometimes there are software packages that don't realize that people can have multiple monitors, and then sometimes they don't have multiple monitors. So if you notice in the lower right-hand corner, I have TechMaker available right here. Now look, when I click on it, what happens? It goes off my screen to the way I had it in my office before coming here, where I was using the TechMaker in my left monitor. Okay. Well, today's really started off well. At least you don't have to walk out in the rain to get to class. Let's see. We'll open up in a different one. I know, we'll open up this. This is a different software package that can handle the tech that I didn't tell you about, but I'm not going to really do much with it. I just need to show you certain things. And let's see. So just for future reference, this is actually the software package that I often use with R to type my programs in. Okay, so we had just started talking about this biometrics paper that was constructed by what was then a PhD student of Josh Trebbs, and the student's name is Chris McMahon, when he was doing his dissertation. And there's a lot of stuff in here, and again, the purpose of looking at the LaTeX code is so that you get comfortable with doing stuff in LyX. And also at times in LyX you need to know what the LaTeX code is. And so because of that, I'm going to say mainly here, just take a look at this file after class on your own. And try to correspond the code to what's actually produced in the PDF. And I just want to point out a few specific things about this code. So first of all, if you remember, every LaTeX document starts with the /document class command. Notice there are comments up here. Well, that's okay. You can include comments before that. But if I come down here, you can see the document class is called Bio. That's because this journal, Biometrics, has a particular document class file that they've created to help you write papers for that journal. And it's called biome.cls. And with this, then, they also have a variety of different options of how to do stuff. And of course, that's always in the square brackets. One in particular I want to mention is that they have this referee option. So, let's say that you are submitting the paper to the journal, and referees are going to review it to judge whether or not it's worthy of the journal. And by using the referee option, it will nicely print off everything double-spaced. Well, I'm sorry, yeah, in terms of there's, for some reason, I'm not remembering the exact term, double-spaced meaning, there's an extra line between every typo. Is that the right word? Or not? Yes. Anyway. Now if I take that out, then, that option, and you compile the document, then the document will look exactly like it does in the journal itself. And so this then again shows you how these journals or other professional atmospheres where there's a certain style to how the text needs to be, they often use LaTeX to do that. Okay, the next one I want to take a look at a table. And does anybody by chance remember what the environment in LaTeX is called for tables? / never try to do this in LaTeX? I'm not good of a joke. Does anyone remember what the table environment? Tabular. Yeah. Oh, I know it's in there. Okay. Everything's working great today. Let's see here. I was just misdoing it. I wasn't doing it right. So here's an example of an actual table. Let me show you what it looks like in the PDF. Now, it's typically standard practice whenever you submit a paper to a journal, you put all your figures and tables at the end of the document. So this is the actual table. It's not that difficult of a table. If you look at it in Word, it wouldn't take you very long to construct it. But again, here's all the corresponding code that was needed to construct that table. And, it's a mess, to be honest. I just wanted to point that out to you. And then lastly, the last thing I want to point out to you is a particular environment. Okay. Remember how we were using /section to get, let's say, section 1 actually listed? Well, there are times where you don't want the actual section number printed at all. So, for example, in this particular case, let's look at the PDF. So, for example, here's section 6. So this is like the end of the paper, discussion of the results. So that was done by /section. Then we come to acknowledgments. Is that section 7? Essentially it is. But if you don't want it to actually be printed as 7 dot acknowledgments, which is not what's usually done in practice, you can do /section asterisk. You will see that in some of our LyX stuff. That's why I want to bring that up. So if you want an unnumbered section, put asterisk at the end of it. Okay. So let's finish this off. Let me, shoot, hold on. Okay. So some other examples. Some of you will be actually writing a dissertation. Others of you will sometime need to, in our academic environment, construct something that is like a professional report or something like that. Well, there is a particular template, not template, a document class that you can use that corresponds to the UNL dissertation guidelines. And you can download it from the math department there, and I think I include a link to it on our website. And then lastly, in R, you can actually have, I know obviously we haven't really gone over this, but in R you can actually have it actually write LaTeX code for you. And let's say if you want to print off a data set. Well, you can have it printed off, but print it off in a LaTeX code format. And you just copy and paste the code that comes back to you as output. The LaTeX code that comes back to you as R output, and you can put it in your LaTeX document. SAS has something very similar as well. Fortunately, I failed to put the SAS part in there. If you're interested, come talk to me sometime later in the future. Okay, any questions? Okay, so now let's go into talking about LyX. As I told you before, I first started using LyX when I started writing my my book on categorical data analysis. Started writing it in about 2010, and before that, I didn't even know that LyX existed. And to be honest, I would say probably most statisticians don't know it exists, and many professors who expect their students to, let's say, type a thesis or dissertation or some other work like that, they will often require their students to use LaTeX. Well, the problem is then it takes a long time for those students to learn how to use LaTeX properly and stuff like that. And when in the end, if they just introduce the students to LyX, it will be a lot easier. The students will save a lot of time. So, what is LyX? Again, as I've said before, it basically gives you a word-like interface to using LaTeX. It's really slick. So, Word itself is based upon the WYSIWYG, or what you see is what you get philosophy, meaning what you type in Word is then what is given to you if you were to print out a Word document or if you were to make a PDF document. LyX is based upon what the creators of LyX call the WYSIWYM philosophy. What you see is what you mean. What do I mean by that? Well, here's an actual LyX document I think that can kind of help illustrate this. So this is the first LyX document that we're going to look at. It's based upon the first LaTeX document that we looked at as well. And if you notice here, a second. If you notice here, normally in Word, what you see at the very end here, like sigma squared, that's going to be all the way over to the right-hand side of your page when you print it off. What you see is what you get. But look what happens then when I make my window smaller. Notice how things are starting to wrap. That text is starting to wrap. Well, does that mean now when I print off this document, now this line stops with width when it's printed? No. Rather, again, what LaTeX does, it takes your words and it properly arranges them on a particular, in what's usually done a PDF, so that everything works or looks rather nicely. There are certain algorithms that it has available for it to decide where to move on to the next line. And so what LyX does then is LyX creates the LaTeX code for you, sends it to MikTeX. MikTeX then spits out the PDF. And whether you're looking at the document like this or like this, it's going to look at exactly the same in the end. And so what you see is what you mean, I guess, kind of is based upon that idea of, well, I don't necessarily always want to stop my line there. Just arrange the text, arrange the words so that it looks nice on a document. That's my basic definition or understanding what you see is what you mean. Now, again, LyX is free, and in a previous class I showed you where you can download it. If you haven't done it already, please make sure that you do download it and install it on a computer. Now, there are other software packages that do a similar thing as LyX in terms of providing a word-like interface to LaTeX. As far as I know, none of them are free. The most popular one is one called Scientific Word. And that was even around when I was a student. Shoot, I forgot to close it out. Let's see what the price is. So, $899 for commercial usage. Ooh, in academics, as a faculty member, I can get it for $799. And as a student, you have a big bargain. You can get it for only $286. But LyX is free. So, that's why we don't need to bother with that. So, we're going to talk about this Hello World document once again. It's based upon the first LaTeX document that we saw before. It's not exactly the same. There are some minor differences to it, just to show you what LyX can do. Do note that this is again pronounced as an L-I-C-K-S, LyX. I am not controlling how this is actually typed out. If I just type LYX, LyX essentially then forces that Y down as kind of like how LaTeX is done. I'm not doing that myself. Okay. So where's my PDF? Close it out. So this is my PDF that's created by LyX, and you can see again it's very similar to what we had before. I just want to point out a few things here before we get into looking at the corresponding items in LyX. Obviously, I have a title, I have my name, I have the date. There are a number of sections that are denoted numerically in the document. There are a number of places where I use mathematical equations in the document as well. Notice the table in the document. Notice the cross-reference in the document too. Okay. First of all, as I said, LyX creates the LaTeX code. So this is now on page 4. If you want to see the LaTeX code, view source pane. Make sure over here it says complete source so you can see the complete document itself. The default is current paragraph. It's just complete source now because I was walking through some stuff before class. And so this is the complete LaTeX code that will be used or sent to MIGTech to create a PDF. So notice here, /document class. I know that's small, but I cannot make it any larger. You see it's an article. Okay? And they're specific about an option, English. Let's move down. So notice here's the author information, title information, begin document. This make title forces then the actual author and title to be printed. Sections. Notice here's my math as well. Notice here's the table, the tabular environment. And so you get all this stuff. Now, unfortunately, you cannot edit that. You cannot edit that LaTeX code directly. The only thing that you can edit is the stuff up here in this word-like interface. I think they can make LyX better if they would allow you to edit this and then see the changes up here, but they don't allow that. And you might be thinking, oh, that's not a big deal. But I might have mentioned this before. There's a number of software packages available to help create websites, for example, or web pages. A common one that's used is Dreamweaver. If you by chance remember this other one made by Microsoft called Front Page, which is now defunct, you could do exactly the same thing. And basically the way that Front Page and Dreamweaver was set up was up here you would see what the web page would actually look like to a user. if it was on a web server. And then down here, you would see the HTML code. And you could edit the HTML code, and it would change up here. Or you can change the stuff up here, edit it in like a Word-like interface, and the HTML code will automatically change. Unfortunately, they don't have that available. Now, I rarely will look at the LaTeX source. The only time that I do that is if I can't figure out why, when my PDF is created, it's not working as I had expected. And there's been very few occasions where that has actually occurred. It's the occasions where that has occurred, without getting all the details, is, since you're using this Word-like interface here, how you, how should I say? Maybe I want to highlight this word and make it bold. Well, you don't see the actual code that goes behind it. And, perhaps, here's an example. Here's a good example. Suppose I highlighted variance and also this space here as well. And I say, make that essentially a Courier font. Well, the way that LyX is going to react then is it's going to use the corresponding LaTeX code here that will do variance and that space. The problem, though, is since a Courier font has each letter exactly the same width, you're going to get this space to be that corresponding width that you would expect for a Courier font. It's a minor thing, but at times that can be frustrating. Where instead, if I would just highlight only variance itself, you would get probably what you would want. Okay? Again, it's minor. If you really want to know other examples, I can show you some examples with my book. Okay. Let's talk about spell checking. So, can you see this? So yeah, it says my last name is misspelled. Ha. It says that this word here, so, is misspelled as well. Denotes it with a red underline. And you might think, oh, of course that's going to happen. By default, it will not happen. You have to actually turn on the continuous spell checking yourself. How do you do that? Notice this little thing up here, and if you see where my mouse is, you see ABC with a red line underneath it and a check mark. That means I want continuous spell checking to occur. There's other ways that you can do that as well by saying Tools, Preferences, Language Settings, Spell Checker, Spell Check Continuously. And then, as you would expect, with all these little icons here in these toolbars, there's a corresponding, set of things that you can click on in the menu structure to do exactly the same thing. There is no grammar check, which I find disappointing. Not that Word's grammar check is perfect, but it does help catch sometimes things that I do wrong. There is no grammar check, though, so you got to make sure you're good with your grammar. Let's talk about environment. So we talked about, for example, the tabular environment. We talked about the section environment earlier as well. And in some environments, not all, but some environments corresponding to a document class are available to you right in the upper left-hand corner. This is a drop-down menu. So now, right now, I'm in the title environment. It's the title of my document. Suppose I want to change it so it's not given as a title, rather it's just normal text. How do I do that? Click on Standard, and look what happens in the document itself. Here, section environment. Look what is highlighted. Section. Suppose I want to change it to a subsection for some reason, and it's changed. Suppose I want to create a new section here. So we'll call it new section. Notice by default, it was the standard environment. So look what's up there in the upper left-hand corner. If I want to change that line then to a section, I just click on section. And notice how all the numbering systems will update automatically. Okay. Speaking of environments, let's talk about equations. You don't insert an equation or say something's in a mathematical equation environment by doing that same thing that we just talked about. Rather, let's say if I want to insert an equation, we'll just do it here. I can come up here to insert math. And notice what happened when I did that. Do it again so you can see. So I'm going to come up here, come up to the sigma, insert math, and some toolbars came up. And I cannot make these bigger. I'm sorry. And these toolbars will give me a nice point-and-click interface similar to what you would have with Word's equation editor or with MathType to create the necessary equations. So for example, let's say I want to do a little fraction. So I come over here to an icon that looks like fractions. Click on it, and I have a whole bunch of different kinds of fractions that I can insert. Standard, let's say, and I do 1 over 2. Let me see if I can make this bigger. Let's see, display. Nope, that's not it. And it looks a little bit better. Is that okay? Okay. And so, also what I can do, let's say, well, let me do this. Right now, this is an inline equation. By default, these will always be inline equations. Now, I might want to have an offset equation, or what's often referred to as a display equation instead. So when I'm in the equation itself, I can come over here to where you see Set Display Mode in the lower left-hand corner, and if I click on that, look what happens. It now is an equation that's offset from the main text. It's not inline anymore. It's a display equation. I can click on that icon again to get an inline equation. Notice how in the equation itself it is surrounded by what looks like kind of like a pink a corner border all the way around it. That just shows you are in the equation itself. When I just hit the right arrow, notice I'm outside the equation, my toolbars disappear. So let me hit the left arrow to go back into it. If you want the toolbars to always appear, you can simply do View, Toolbars, and then you can say, I always want, let me try that again. I always want those to be available to me. So now when I'm outside the equation, I always have those toolbars. Now, of course, you can arrange these toolbars to wherever you want them. I tend to always put them at the bottom of my screen, but you can put them at the top of your screen. You can put them elsewhere. You can move them around just like you would other kinds of toolbars. Now, you can actually type LaTeX code inside this equation to get the corresponding equation or symbol. So for example, if I type /alpha and then hit a right arrow to say, hey, I am done, look what happens. It automatically inserts alpha. And if you get really good and you understand the various LaTeX commands, like think over will give me a fraction, /over, and look what happens. I get the essentially I could do a fraction now. Oops. Let me come over here. Now notice I am between the half and the alpha. Now if I hit the left arrow once, look what happens. See that little pink part that comes up around the fraction? That means now I am dealing with something inside that fraction itself. And that's going to be more important later when we have more complex equations, because oftentimes it's hard to figure out exactly where you are in the equation itself, so that if I start typing now, notice that means I'm in the denominator. Where if I was up here, I'm not in the denominator. I'm not in that fraction anymore. Okay. Any questions so far? Yes?
So like to insert like these Greek letters like alpha, so you don't have that thing you have in the word. Do you always have to type it? Or?
Oh, I'm sorry. Yeah, I probably didn't go over that as much as I should have. So here's another way to insert alpha. You just come down here to where you have the Greek letters. So you see that it says Greek? And now you have the corresponding menu pop up, and let's go ahead and insert an alpha again. And there you go. If you wanted to do an uppercase alpha slash capital A alpha. Oops. What did I do wrong? Slash. Well, maybe I am mistaken there. Okay. Well, it works for gamma. Slash capital G and A and then A. You get the capital letter gamma. I'm not for sure why that's not happening with alpha. And again, I don't know how many times I've ever used the capital alpha before. Okay, any other questions? Yeah.
So if you're typing in normal mode, could you just like do a $sign to quickly jump into math mode if you don't want to point and click?
You cannot just type a $sign to do that, but what you could do is that you could actually use LaTeX code directly. So notice this little tech icon. So I click on that icon. Now I have this red box, slash alpha. Oops. And then do it like that. You could do that. And when this compiles, this will actually create what you would expect.
Okay.
I don't know, maybe if you're used to LaTeX, you find that maybe faster to do. I find it to be, in the end, maybe it can be slower for smaller things like that, but definitely for more complex equations, I think it's a lot better to use the equation editor itself. Also, if you really wanted to, you could copy and paste that code out, and you do get the code back. Let's talk about comments. Often they're very helpful to have. If you want to do a LaTeX comment, meaning what would start off with the %, you just simply click on Insert. There's Note.
Little branch up.
There, thank you. Comment. And notice you have a little box that pops up. You type your comment in there. If you want to, you can minimize it by just clicking on that. And that's your regular old LaTeX comment. There are also LyX comments. That's what you see in yellow. How can you insert that? Well, through the exact same means that I just showed you before, but instead you do LyX note. Alternatively, what's easier, you come up here to this icon and click on that. Oops, let's actually do it outside. And now you can type your LyX comment. When you are actually compiling this document, I'll show you how to do that later, to create the PDF, all those LyX comments are removed. They still appear in your document here. Notice this is a .lyx file, so they will still always appear in that document. It's just when it's sent to MikTeX, since this is native to LyX itself, LyX removes it. Comments like this are extremely, extremely useful. I guess to save time, I won't show you this, but very often when you're editing a document with someone else, like a co-author on a paper or a book, this is a great way to communicate back and forth between each other. regarding, oh, I don't like how you worded that. Let's change it, or something like that. And if we had more time, I'd show you my book, and you would see these LyX comments just all over, which is one reason why it took us so long to write the book, because we kept on communicating this way. But anyway, trust me, this is a great way to put a comment in a document. What about inserting blank lines or spaces? Well, just like with LaTeX. Suppose I want to insert a space in front of the word from. If you see where my cursor is right there. If I hit space, as you can hear me do that, nothing happens. Because why would you want to do that in the first place? It doesn't make sense in regular writing. Also, let's say if I want to insert a blank line between these two lines of text. So let's say if I hit enter, I can do that. Now it's expecting that, hey, I'm going to type something. But let's say I want to insert two blank lines. See, I'm hitting my enter key, nothing's happening. Because again, why would you want to do this in regular writing? And let's say that, oh, I'll come back and deal with this blank line later. Maybe I want to actually insert something. Let's say I want to come back to it, and I'm going to go back up to section 1. So I'm going to click my mouse, go back up to section 1. Now look what happens to that blank line. It disappears. Because again, why would you want to have a blank line there in the first place? Now there are times where maybe you want a space for some reason. How could you do that? Let's say if I want a blank line. Insert, formatting, vertical space. You have this window that pops up. You have some predefined, depending upon the document class itself, some predefined space lengths or line lengths, or I guess vertical space lengths, that's a better way to put it. I'm going to just come here to custom. Let's say if I do 1 inch, I could use a different unit of measurement if you prefer. And now when I hit OK, now I will have an inch there, and in the PDF file, it will be an inch. You can do a very similar thing with horizontal spaces. Insert formatting. One way to do that is with horizontal space. I'm not going to go through that. You can put paragraph symbols at the end of paragraphs. So, you might be typing a few sentences, then you want to start a new paragraph. Well, what do you do? If you hit enter, of course, you go down, now you start typing again. You can turn on paragraph symbols. I think this can be useful when you're using LyX. So you can see the usual, I know it's kind of hard to see, but the usual paragraph symbol that you would have in normal, I guess, grammar context. And you have to actually turn that on if you want to see it. And I give the step-by-step directions in the notes of how to turn it on. Let's see here. I think that's a good place to stop. So let's talk about the exam. I will just say, in case you want to get going on this before our next class where we talk about this, if you want to compile to create the PDF, come over here to these little eyes there. That means you want to view it. So if I click on that, it sends it to MikTeX, and there you go. There's my PDF. That's all you have to do. If I were to, let's say, make changes to the document and I want to see how those changes are going to affect the PDF, I can come over here to the update, and it will automatically create the new PDF based upon your current LyX document. Okay. Are there any questions? Okay, so let's talk about the test. So again, it's going to be in this room, 12:30 to 1:45. I do have this room reserved for a few minutes after that. So if there is a strong demand for more time, you can have it. I have the room reserved. I have to check, it's either 2:15 or 2:30. Okay? I am writing the test, so it's an hour and 15 minutes long. But I understand, too, that this is the first time that many of you have taken a test like this, so that's why I made available the additional time, if needed. We'll just see how it goes. Just plan on finishing at 1:45, and then we'll make a decision. Again, this will be only over the SAS material, and then LaTeX or LyX. Although if you really wanted to, you could type up your answers in LaTeX during the exam. Just don't blame me if it's going to take a little bit longer to finish. The test itself, there's 100 points possible. I just choose 100 points because it's easy for me to figure out a percentage grade. And that because this is weighted as 100 points corresponding to the 50 points for an assignment or something like that. You know, this exam itself is worth 30% of your grade, so it's a huge part of your grade, but that's why it's called a midterm. So problem number 1 has 35 points. There are 3 parts, and it requires for you to write code. So I might say, oh, construct this plot, or estimate this regression model, or find the mean and standard deviation for these particular variables, something like that. So you're going to have to write code. Problem number 2 is worth 36 points. There are 5 parts. I give you the code. This problem is constructed in a way that you should not have to run any of it in SAS. You should not have to. I understand there might be, 1 or 2 parts, let's say, that, oh, you're not for sure what the answer is, so you're going to try to run it in SAS. But just realize, in this code that I give you, there's going to be a data step at the beginning that would normally contain data. I should say, normally would contain data. I don't give you the data. The data is excluded because you shouldn't have to run this in the first place. Then I have maybe some other data steps, maybe some procs after that. So, do I have an example of a question? Hold on. Here's the test if you want to see it.
Okay.
So I might ask you, maybe I'm reading in some data, and I might ask you, why did I put this particular symbol or code to read in the data? Why did I have to do that for some reason? I think, did I give an example in the listserv post? Yeah, okay. So like the @ symbols. Well, why did I need the @ symbols? Or what does the @ symbols allow me to do when I'm reading in data? So that gives you an example of a type of question. I might, let's say, maybe give you, maybe I have proc means. You do some proc means to calculate something, and I might ask you, okay, this is going to produce the mean. Well, what if I want also a standard deviation? That's a simple problem. But that's what I'm talking about. Maybe I give you some plotting code and say, well, how could I change the axis title from the default? And like an x-axis title. So again, those kinds of questions, you don't need to run the code. And in fact, it could slow you down to run the code. And so I recommend that the only time that you ever attempt to run the code in that problem is, let's say if you do have time, You can go back, maybe construct an example data set of your own, and try to run it and try to figure out the answer. So number 3 is 29 points. There are 4 short answer problems that are not connected in any way. So problem part A has no connection to part B. I think I might have given you example problems, what I mean by that before, but I guess it doesn't hurt to give this again. So one potential problem would be, what are 3 ways that one can figure out an appropriate ODS table name? Well, there's help, print stuff to the log window, print stuff to the output window, and also the results viewer. Might give you some information about that too. Or the what?
You did it.
I did do it. Okay. The name is escaping me of the exact window name. Maybe I give you this one too. What library are all the data sets created by SAS stored in by default? Does that sound familiar? Work. Okay. What happens to these data sets when SAS is exited? Deleted. That's supposed to be a simple question. Okay.
Are they going to be that short?
Some may be, some may not be. I can give you some example code, and I can say, tell me what's wrong with this code. Why won't it work? Fix it. I could ask you to write a very short segment of code as well. What I tried to do with this test is to make sure that I am having questions or points corresponding to every single main part of what we discussed, like the intro section, the data summary section, the graphics section, all the way down to matrix algebra. So there's something from everything. So don't say, screw it, I'm not going to do macros. He won't ask a question about that. I will. So again, this test is 30% of your overall grade. Perhaps what you've seen in some other courses this semester, I do not scale. I have never, ever scaled an exam in my 20 plus years of teaching college courses. I do not plan on starting to scale exams. The grade that you get is the grade that you earn. I hope everyone gets A's on the exam. I'd be very happy with that. But I wouldn't, if the grades dictate this, I'm not opposed to give everyone C's or even lower. Okay? This exam should not have surprises on it. I typically on my exams have a significant proportion of students who do extremely well. But I will also have a small proportion of students who do poorly. And when I ask them, okay, well, what caused you problems on the exam? Was there any surprises? And they'll say no. You've went over all this stuff. Just for some reason on the exam, I didn't do it, or maybe I didn't study enough so that I could get it done in a test situation. Now, so while this is the first time, obviously, I've written an exam for this course, I tend to write my exams similar from one course to the next. So what are kinds of problems that students have problems with on my exams? A typical question might be where there are more than one part. So maybe I'll ask, I have an example here. This is very simple, so maybe I say, okay, why is something true? Explain. So there's 2 parts there. And so if you just give me like a one-line answer, well, that does maybe the why part, but it doesn't necessarily explain, why your answer is that. That's maybe not the best example in the world, but my main point is, make sure you answer all parts of a particular problem. Watch out for multiple question or multiple aspects of a question. Also, make sure you're answering the correct question. Sometimes I will have students answer one question because they know what the answer is, but the problem is that's not what I asked. And again, I wish I would have a good example of that related to maybe what we're doing here. Maybe this is the best example, but I'll try. Suppose the question says, so how can you output like the means into a data set from proc means? Show me how this can be done using the output statement. Suppose somebody answered it using ODS instead. That's what I mean. You're answering the wrong question. It's maybe too simplistic, but that's what can happen. And so because of that, then obviously I cannot give full credit for not answering the correct question. So the test structure itself is, again, you will be using the computers in this room. Again, make sure you're comfortable with using these computers. Spend some time doing that. Obviously, computers fail at times. Fortunately, we have backup computers that are available to us. But also, this might be useful for you to do is bring a little USB drive so you can save stuff on during the exam in case for some reason you do need to change computers or maybe the computer dies. Save stuff to your USB drive. Where are the USB drives? They're actually like right behind there. Yeah, so you can stand up and see. Yeah, it's not as convenient as you would expect. So at the beginning of class, what will happen is I will make my, the test itself will be in a Word file. I will make that Word file available to you on my course website, the Graded Materials webpage. Then at 12:30, you'll be able to download it to your computer, and that's where you need to put in all your answers for the exam. This includes SAS Code, the SAS output that is used to help answer a particular problem. Organize it similar to what you would do for an assignment. So I always need to see the SAS code and output corresponding to some problem that you're answering. Then obviously there's going to be times where you're going to need to type an actual sentence or something like that. Again, type it in the Word document. Save the Word document during the exam multiple times. So don't just wait until the end of the exam and uh-oh, your computer died and you lost all your work. Perhaps I'm just overly afraid, but when I'm typing stuff like in Word or other documents, I often save it probably every 5 minutes or so that I don't lose something. So we all know that Word can crash. Okay, don't lose the time when Word crashes. Make sure you save that document. As I said in my listserv post, if a problem asks you to, or you need to actually, let's say, write some kind of equation, you're welcome to use the equation editor in Word to type it out. But I understand that maybe you're not as comfortable with it, or it might take longer. It's okay for you to write it out in equation in words. Like if you need y hat, go ahead and write out y hat. And I think the example I gave in the listserv post was, here's my regression model. I would still expect to see that y hat, or the hat part, for full credit. Because putting y there means something else in statistics. It's not the estimated regression quantity anymore. Also at the beginning of class, I will actually pass out a paper copy of the exam too. Don't write your answers on it. It's just there as I don't know, I thought this might be a helpful tool so that when you're doing the exam, you don't necessarily need to flip back and forth between different, between SAS and Word as much maybe if you had a paper copy of the exam. Maybe use that paper copy of the exam to, let's say, check off particular problems that you think you have solved. Now, you finish the exam. What do? Well, you need to give it to me somehow. The way that I set up is you're going to hand it in via Blackboard. Okay, so my.uno.edu, you go to our particular class website on Blackboard. What will come up, see test quizzes. You already did the day number 1 quiz. I've also added now midterm. So you click on midterm. And of course you have to click so many times to get to where you want to go. You click on continue. Then, one question. Turn in your test here! Exclamation mark. Browse to where it's located on your computer. Attach it. And then make sure you select Save and Submit. Do not say Save all answers. I don't get it that way. Save and Submit. When you do that, you'll have some kind of confirmation come back to you that, oh yes, you have turned it in. Get a screen capture of it. Because then that proves, if for some reason I didn't actually get it, that proves to me that indeed you did turn it in. Obviously, too, make sure you turn in the correct file. Don't accidentally, let's say, turn in a blank document, the blank Word file that you first downloaded before you did anything to it. Let's say you downloaded it and then you decided to change the name, you decided to copy it, make it a different name, and then instead you accidentally turn in the original blank document. Make sure you turn in the right document. Obviously, too, make sure you have you keep a final version of what you turned in yourself. Okay. So again, the test is closed note, closed book, but you do have access to any of my programs that are available on my course website. You cannot use my lecture notes. You cannot use past assignments and their corresponding answer keys. Only my SAS programs. Make sure you don't over-rely on these programs. At this stage of the semester, you should have run all my corresponding SAS programs. You should have a general idea of where to find stuff. So, for example, let's say I ask you to merge 2 data sets. Give me the code that does that. Hopefully you think, okay, well, where did Chris do that? If you don't remember off the top of your head, it's the merge statement for a data set. Okay, Chris used, you go through my programs here and you remember, oh yeah, I remember Chris doing that. That was in the data steps section and, merge.sas. Perhaps that's an overly simple example, but that's what I'm looking for, that, don't overly rely on those. If you're spending 10 minutes looking through a program trying to figure out how to print a data set, you have not studied enough. Okay? So what are some things that are not allowed during the exam? Obviously, do not communicate electronically with anyone in or outside our classroom. Don't get on the SAS technical support website and get into their chat facility and say, hey, how do you do this in SAS? Don't do that. Don't have my lecture notes open, obviously. And keep your eyes on your own computer screen. Obviously, we have a kind of a small room here. It can be tempting to look around that big monitor and see what somebody's doing in front of you. Don't do that. Also, try to spread out in the room as much as possible. I mean, we have four for you right back there. You might want to spread out more. Also, on your exam itself, your Word document or even your SAS program, make sure you're not using like a size 50 font so that the person behind you could actually see it rather easily, what you're typing. And then lastly, please note that I can see what's on your computer screen. Similar to those of you who are TAs in our department, you know that there's a software package called BTutor that's on some Hardin 49 classroom, for example, if you've been in there. And that BTutor software allows me to see what's on your computer screen right up here. And I will be periodically viewing what's on the screens to make sure that there's, you don't have like my lecture notes open. Okay? In the 10 plus years I've done electronic tests, not necessarily always of this format, I think I've only caught 2 students cheating. It was actually in this classroom. One of them it was actually that classroom where I told the student, you got to close my lecture notes. And then, I don't know if he didn't understand me or not, he kept the lecture notes open. And he kept on doing it. Not sure why. Anyway, that's again a story for another day. So, that's the general structure of the exam. We will spend the rest of the class reviewing the corresponding material on the exam. Before I get to that corresponding material, do you guys have any questions about like format issues and stuff?
The parts on 1 and 2, do they build on each other? Like question 1, the
No.
3 parts, they don't build on each other?
Oh, well, like problem number 1 has 3 parts. Like there is some connection between them because they're using the same. They're using they will essentially be using the same data set. But I word them in a way so that, so part A is very important. Part C doesn't rely on part B doesn't rely on part C. So that helps you out in terms of partial credit. And that reminds me of something I did want to talk about, and that is partial credit. Obviously, you need to show your work on every single problem. Again, if you use SAS for, if you use a SAS program to do something, well, give me the SAS code. If it generates some output, show me the output. You may be faced with a situation where you can't get the SAS code to run. For some reason, you're just not getting what you need to answer a particular problem. What do? Do you just leave the problem completely blank? No. Again, there's going to be partial credit, but you have to show me some work. So what could you do? Is that you give me the code that you've tried, and you say, I just can't quite get it. I think maybe the problem is there. And depending upon the information that you give me, then corresponds to the amount of partial credit that I could give you. For example, let's say you forgot a semicolon for some reason. Well, the amount of partial credit I could give you is probably a lot, because all you are missing is a semicolon. If instead, let's say you're trying to use proc means to estimate a regression model, well, I might give you what I call a mercy point, because you did attempt something, but you're far from the right answer of using proc reg to estimate that regression model. Okay, so always think in terms of partial credit. Never ever leave a problem blank. Are there other questions regarding format issues?
Not format,
Okay.
actually, in the assignments you usually tell us to put the entire code and the entire output. So, like in the examiner, so we need to put the entire output that we get is something that is related to the question and we need to interpret.
Anything that's used to answer a problem, I need to see. Now, there's not going to be a place where you're going to have, let's say, 50 lines of code with 5 pages of output. You're just not going to have that. So, I want to see like what's on the assignment, but I don't think it's going to be overwhelming what you need to provide. Does that answer your question? Okay. Other questions? Okay, so let's talk about the material on the exam. So we started off in what I call the introduction section. I guess one nice thing about the exam is that obviously this material has kind of built upon each other, so the stuff that's in the introduction section or some of the earlier sections should be quite easy. But remember some of the terminology, such as the different window names that we have for the various aspects of SAS. And what do those windows do? Obviously, make sure you can do a comment in SAS. So for example, what does that kind of code allow you to do in SAS? Bulk comments, I think that's a good way to put it. So that could be a short answer question. Now, the way that SAS is set up is that pretty much all its calculations are done in data steps and procs. That's just how it's organized. We spent a lot of time in this section talking about reading in data, and then also we'd spend a little bit of time talking about exporting out data. Make sure you're familiar with how to do that. So for example, one of the things that we talked about with export, we talked about a few different ways, proc export. We also talked about how to use a data step, where we use that underscore null underscore. Why we would want to do something like that, or use that syntax. Then we went into the data summary and analysis section, where we focused on 3 procs: means, reg, and freak. Obviously understand what those procedures do, understand the common statements that you often find in procs, such as var, by, class, output. And then that then gets into, well, how can you, how should I word this? How about output information from a proc to a data set? How can you do that? There are 2 main ways. You can use an output statement. You can use ODS. And what does ODS stand for? That might be a simple short answer question too. Output delivery system. Many procs allow you to have a statement and then some options after that statement. What's the big way to do that option? You use that slash there that separates the main part of the statement from the various options. And of course, make sure you can read output. Here's maybe some output from proc reg. Tell me what the estimated regression model is. That would be, again, a simple problem. Then we went into graphics, and just to save time, we focus on the SG procedures. So don't worry about just the plain old G procedures. Remember where these SG procedures come from. Basically, they were written to take advantage of the ODS graphics that were installed in SAS prior to these SG procedures. Obviously, you know how to use proc SGplot. But make sure you understand how to make graphs look nice in terms of like grid lines. How do you do that? How about legends? Axis titles. Control various colors. Control various symbols. How do you do all that? So maybe a question that does build, I guess, 2 interconnected questions might ask you to do a plot in part A, and then in part B, I ask you, okay, now let's make it look fancy. Give me some grid lines, nice, don't use the default x-axis, y-axis titles and stuff like that. Then we got into the data steps section, which looked at data steps in a little bit more detail. The first thing that we did was we were talking about how to create a permanent SAS data set. You have to create the library, the syntax. You might say something like Chris dot the data set name. And why would you ever want to create a permanent SAS data set? We talked about conditional execution. I apologize, we're going to go a little bit long here because I've been using this clock, unfortunately, as a way to keep track of time. And according to my computer, it's a 1:42, and that clock says it's 1:34. I should have realized that because I've taught in this room before, and that clock has been a problem. I haven't taught in here for a while. So conditional execution, like if then else, inside of a data step. The concatenation of data sets, vertical and horizontal. So the vertical, you can say like data set 3, set 2, set 1. And so what that's going to do is put set 2 here, set 1 right below it. Obviously, those set 1, set 2 have to be structured the same way in order for this to work. For the horizontal concatenation, that's where the merge statement can be used. And while this wasn't a data step, we talked about how to use proc transpose. Because very often you have to change the layout, you could say, of a data set in order to use it in a particular procedure. And proc transpose can be helpful. There are summary functions like max, min, sum. Remember, there was various formats to use with those functions, such as the of statement or the of word to do certain things. And then we spent a lot of time talking about what you can do with probability distributions in SAS. So, find a quantile, find a probability, find a density value. You do random number generation. Make sure you can do that. I can say, well, generate 10 random numbers from a normal. Use this seed. So then you use one of those call functions to help with that, the stream in it. In that context, too, this is when we started talking about do loops. Make sure you can do a do loop. Then we got into macros. There are two types. There are user-defined, and then, or user-created, and then predefined. We started off with the predefined first. We talked about some simple ones like let, %let. What does it do? Well, it creates a macro variable. How can you use that macro variable? Well, you have to use an ampersand with it. I could ask you to create a macro function. Make sure you know the syntax associated with that. Now with macros, sometimes you don't get it right the first time you write it, and you have to figure out, well, what did you do wrong? And there are various option statements that you can use to help you diagnose the problem by looking in the log window. Make sure you understand what those option statements are and how to use them. Then with macros too, you have loops and conditional execution available to you. Like %do or %if. Make sure you can use those. Also, where can that code be used? Can you just put it anywhere in a SAS program? It has to be inside a user-created macro. And then lastly, how to create a macro variable from a data step. Make sure you can do that. And then the last section itself was matrix algebra. Obviously, proc IML. Make sure you can do some basic calculations like multiply two matrices together. Make sure you can get data into proc IML. Remember, it's not the data option. So you have to do it a different way. And how do you get data out of proc.iml? Again, it's not like an output option. And with proc.iml, you always end with a quit. Lastly, as a reminder, remember that all these classes are recorded, so you can do some binge watching over the next few days to relive your past experiences in this class. Okay, so that's all I have specifically to say. It is 1:47 right now. I apologize for going long. Do you guys have any questions? Yes.
So, like, when you say we have the programs available, so is it like the website, your web page?
Yes.
So all the programs in the web page?
Yeah. You don't bring those programs to class with you. You only bring, well, they're available on my website. Now, obviously, if you bring in a USB drive, what should be on that USB drive? Nothing. I will check. I should say I may check. I'm not necessarily going to do that, but seriously, don't put anything on that USB drive. Only, it should be completely empty. The only thing that you can put on it is eventually your test. Are there other questions? Okay, then that's it for today. If you still have some time, please take a look at these computers. Note that this computer classroom is open other times during the day. There are classes in here though. At times there is a schedule posted outside the door, so if you need to leave right now, go ahead and leave, and you can come back here another time before Thursday. But otherwise, you are free to go.